What's up, Algebra 1 students? Mr. Ford here with a homework tutorial. This is 511 Part 2. We're looking at problems 12 through 17, and away we go. 512 is going to go right back to the rabbit problem that we did today in class. Jill is studying a strange bacterium. When she first looks at the bacteria, there are 1,000 cells in her sample. So 0, 1,000 is going to go right in our table right away. The next day, there are 2,000 cells. And intrigued, she comes back the next day to find out that there are 4,000 cells. So the first question is, should this graph be linear or curved? The answer is curved. And the reason why, it's growing exponentially. Or I suppose we should say growing by multiplying. It's growing in a timesy kind of way, instead of growing in a plusy kind of way, which is a different way of thinking about things that we're doing here in Chapter 5. Question B says to create a table and a graph of the situation. The inputs are the days that have passed after she first began to study the sample, and the outputs are the number of cells. Now, if you look at the pattern going on here, we are multiplying by 2, multiplying by 2, multiplying by 2, multiplying by 2. So the next day will be 8,000, and the last day will be 16,000. 3 and 4. When it comes to our graph, this is a 10 by 10 graph here, so I'm just going to go 1, 2, 3, 4 here. I suppose I could have spaced those out a little bit more, but hey, who cares? As far as the graph go, I might just count by thousands. Do I have enough? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. Just barely. You know, I'm just going to count by thousands. This is 1,000 there. 2, 3, 4, 5, 6, 7, 8, 9, 10. There is 10,000. And here, up here, I'm going to make an extra tick mark. That's 16,000. So, the first point is 0, 1,000. That's the day 0. Day 1 has 2,000 right there. Day 2 has 4,000. Day 3 has 8,000, basically doubling 1, 2, 3, 4. Each time, day 4 has 16 all the way up there, and there's your graph. And you can see the curve developing because of the exponential growth that's there. Pretty cool. Okay, next question, 513. Write each expression below in a simpler form. Don't let these confuse you. They are very, 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 very easy. All you need to do here in question A is do 723 minus 721. Put that calculator down. Those two numbers are 2 apart from each other. This is 5 squared, or 25, if you want to be fancy. Question B is very similar, only this is not going to be as nice an answer. In this case, you're going to have 3 raised to the 300 minus 249 power, which is 3 to the 51st power. I'm going to leave that alone. I would not touch it. It's not necessary to look at the answer there, or at least the number answer, because that's already a huge number. Actually, hang on. Calculator Cam, what is 3 to the 51st power? It's a very large number. It's 24 digits long, so no, not a thing we're going to look at here. Question C is the easiest question I've given you in a long time. All this stuff does not matter because it's being raised to the 0 power, which equals 1. End of story. Question D, this is a scientific notation problem. Don't panic about these too much. They're actually really simple. The only thing you got to do in the first step is 10 to the 3rd divided by 10 to the negative 2nd. That's going to be 4 times 10 to the 5th power, because 3 minus negative 2 is 5. And then this is all being squared. So we need to do 4 squared, and we need to do 10 to the 10th power, like that. So 16 times 10 to the 10th power. I like this answer. You'll see some people say 1.6 times 10 to the 11th power. Honestly, scientific notation, whatever. I'm not a huge fan of it, but it is worth knowing. Your Mrs. Cotton is going to expect you to know it in science, and so is Mr. Wright. It's just a thing you got to know. So let's look at the next question. Oh, gotta zoom out here. Jackie and Alexa are working on homework together. Jackie says, I got 5, but it looks like you got something different. What solution is right? And Alexa says, I think you made a mistake. Did Jackie make a mistake? Help Jackie figure out whether she made a mistake, and if she did, explain her mistake and show how to solve the problem correctly. Let's see what happened here. I can tell you right where the problem is. Bada bum bum boobity boom boom bam badibidi dop doop dop doobity doo. That is the problem right there. It happened twice. Those are not correct. X plus 4 squared. Oh boy, if we think about this, think about a generic rectangle problem, This is the most common mistake that happens in high school math, honestly. You get x squared. You do get 16, so she's not wrong about those two numbers. But you also have a 4x and a 4x right there. So there needs to be a plus 8x in here. The same thing is true about x minus 1 squared. If you think about a generic rectangle over here, x minus 1, x minus 1, you do get your x squared, and you also get your positive 1. But you have a negative x and another negative x. There needs to be a minus 2x in here. Like that. So that's what's missing. That's the parts that are missing. Did this question ask us to solve for the original problem? Oh, I guess we do need to solve it, don't we? I'm looking at the answers over here. Yeah, show her how to solve the problem correctly. So yeah, what happens is that we forgot about the extra bits when you're squaring something. That's a tough thing to remember. So let's think about this. As far as solving the actual equation, I do want to cancel out the x squareds because they are on both sides and we won't need to worry about them. But what we'll have down here, we'll have 8x plus 16 minus 2x equals, minus 5. Forgot about the minus 5. Equals negative 2x plus 1. I'm just bringing down all the parts of this problem right there. But I'm also remembering to bring down the 8x has got to be a part of the problem, and so does the negative 2x that we got from this part and also this part over here. So from there, the problem is going to take a little bit of a different turn. We're going to have 6x combining there plus 11 equals negative 2x plus 1. Yep. If we add the 2x over, we'll get 8x plus 11 equals 1. If we subtract the 11 over, we will get 8x equals negative 10. And then x is going to be negative 10 divided by 8, which is negative 1 and a quarter, negative 1.25, like that. That's a bit of a tricky problem to answer, especially the back half of it. So be careful on that one. It's pretty tough. But the moral of the story, this is the most common math mistake people make is right here. X plus 4 squared is not equal to x squared plus 16. Okay, let's keep going. 515 on the next page here. What we got to do is we have to, the best way to solve these problems is to cross multiply, or honestly, maybe a better way is to recognize that 6 times 3 is 18. So what number times 3 is going to be 15? And that's a really good way to find the answer, is 15 divided by 3 is 5. That's the answer, m is 5. Normally the way we solve these is by cross multiplying, which is kind of a weird algorithm, but it does work. 18m equals 90, which is 15 times 6. And then m is 90 divided by 18, which is also 5. So whichever way you want to solve it is fine. Oh no, pi over 7 equals a over 4. This is where we are going to need to cross multiply. It's not going to be a nice answer, I suspect. So cross multiplying, you get 7 times a and 4 times pi. You know, I know that your calculator can tell you what pi is, but I would not do that ever. The last thing I would do in this problem is divide by 7. Leave pi alone is the thing you'll hear me say a lot in geometry class, at least. Don't multiply by pi. Don't do it. Don't need it. 4 pi over 7. 516, write an equation for each line described below. First one's really easy. Slope of negative 2, y-intercept of 7, that is y equals negative 2x plus 7. Really simple. The slope goes right there. M is the slope, goes right there. Y-intercept, which is b, goes right there. So they told us m and they told us b. The next question is not so easy to solve. They told us the slope. The slope is negative 32. So it's going to be y equals negative 32x. We do not know what the y-intercept is, though. They told us what the x-intercept is, of 4, 0, like that. Now, a really easy way to find the y-intercept would be to say, okay, I don't know what it is, but I'll leave a placeholder in there. I'll leave a plus b right there. Because they just told us what x and y is. They told us a pair of numbers that works for x and y. So let's plug in 4 for x. And let's plug in 0 for y. And let's see what we get for b. That'll help us solve the problem. 0 has to equal negative 32 times 4 plus whatever the y-intercept is. This has to work because it's on the line. So 0 is equal to negative 128 plus b. And all you got to do here is add the 128 over. And you will get your answer of 128 equals B. And so the complete equation is y equals negative 32x plus 128. And that's a ridiculous answer, but that's what it is. That is the correct answer. So, like that. Okay, and one more question to do is for 517. The dartboard shown at right is in the shape of an equilateral triangle. It has a smaller equilateral triangle in the center, which is made by joining the midpoint to the three edges. If the dart hits the board at random, what's the probability? Wow, we haven't seen a probability question all year. What's the chance the dart hits the center angle? Well, since all four triangles are the same size, if a truly random dart is going to hit the board, then it's equally likely to hit all the spots. Well, that's one triangle out of four. 1/4 is the probability there. I don't really have a good way to explain it other than that that's one triangle out of four triangles, and they're all the same size. The next question, what's the chance that a dart misses the center triangle but hits the board? So it lands either here or here or here. It's a Triforce there for you Zelda fans. Well, that's 3 out of 4. I mean, there's not much more to say about that, and then that's what the answer is. Hey, pretty cool. Has some tricky ones in there, but keep up with it. You guys are awesome. I'll see you in the next video.